Hello viewers, welcome to the third module on Electrical Thermal Appliances Part 2 of the online course on Domestic Equipment Maintenance. In the previous session of this module, we have discussed on two electrical appliances that were automatic rice cooker and electric kettle. In this lecture, I will cover the operation, internal parts, safety precautions and common faults occur in induction cooker. After going through this lecture, a learner will be able to explain the operation of the induction cooker, identify the basic parts of the induction cooker, and get an idea on the safety precautions and some common faults occur in an induction cooker. Now let us discuss the introduction of induction cooker. Induction cooker is an efficient kitchen appliance and a safe and excellent substitute of gas fuel, microwave and other cooking appliances in use. The other cooking methods use flames or red hot heating elements where the energy loss is more. Induction cooker is an electric kitchen appliance based on the principle of electromagnetic induction, which provides a convenient, cool, energy-saving and hassle-free cooking. This cooker does not generate any flame or smoke. It can be cleaned easily and is an environment-friendly appliance to use. It has soft touch buttons and its durability, safety and elegance make the cooking a pleasant and enjoyable experience. Induction cooker uses induction heating to direct heat a cookware placed over it, so the air around the vessel does not become hot, keeping the kitchen cool. Dear learner, now let us discuss the working principle of an induction cooker. The operation of an induction cooker is based on the principle of electromagnetic induction. This principle, which have already discussed in the module 1, discovered by Michael Faraday in the 19th century. It is also known as Faraday's laws of induction, which states that when an electric current flows through a coil of wire, it generates a magnetic field around it and cause a voltage, that is electromagnetic force or EMF, to be induced in the coil. The induction cooker consists of a copper wire placed underneath of the ceramic plate on which the vessel is kept. The alternating electric current flows through the coil, producing a magnetic field. This field induces an electric current known as eddy current in the plate. The current flowing in the plate produces resistive heat, which in turn heats the food. This ensures that the ceramic plate on which the cooking vessel is placed does not get heated in area other than that below the cookware. The cooking vessel used on an induction cooker must be made of a ferromagnetic metal such as cast iron or stainless steel. When a compatible cookware made of ferromagnetic material is placed on the cooker surface, the magnetic field induces electric currents within the cookware itself, creating heat directly within the pan or pot.
I took the induction cooker, I switched it on, and then I put my hand on top of it for a few minutes and nothing. It wasn't hot at all. It was right. It doesn't produce any heat. But then on that same thing, I keep this vessel of water and within minutes, it starts boiling. So the question is, how does an induction cooker cook things and heat things up without itself getting hot? Well, that's what we're going to find out. And it turns out it's due to the science of eddy currents. So what are these eddy currents? To answer that question, let's look inside the induction cooker. If you could open up, then you might see a lot of things, but the most important one is a coil at the center. And we know that when you pass current through the coil, it produces a magnetic field. And that's exactly what happens. When you turn on the switch, there's a current that starts passing through the coil, and that current starts generating magnetic fields. But what's important is that the current is fluctuating. It's changing its direction continuously. It's called alternating current, and it changes its strength. As a result of that, the magnetic field that it generates also keeps fluctuating in direction and in strength. So imagine this is how the magnetic field is generated. It's continuously fluctuating. And that's all that our induction cooker does. It does not produce any heat. All it does, it produces a fluctuating magnetic field. But how does that boil our water? We'll get to that eventually. But for now, instead of thinking about keeping a vessel on top of this, let's keep a rectangular loop of wire. What would happen? Well, because the magnetic field is fluctuating, we have changing magnetic flux through a coil. And from Faraday's law, we know that that produces an EMF. And as a result, there will be an induced current in this coil. Now, the direction of the current will all depend upon whether the magnetic field is increasing, decreasing, what the direction is in terms of Lenz's law, something all we have talked about before, but don't worry too much about the direction as of now. What's important is there is an induced current due to the changing magnetic flux. But now comes the question, what if instead of having a coil like this, what if we had kept a rectangular plate? Now what would happen? Well, again, the flux is changing, so there is an induced EMF. But earlier, there was only one path for the current to flow, but now the entire thing is a conductor. The whole thing is a playground for the electrons, which means your currents will be formed in loops everywhere on the surface of this conductor. And so you'll have loops of current formed on the surface. And these loops of current, which are formed on the surface of a conductor due to changing magnetic flux, is what we call eddy currents. So if we go back to our vessel of water, due to the fluctuating magnetic fields, eddy currents are set up on the base of this vessel. And that's how the vessel gets heated up directly. And then that heat is transferred to the water, making it boil.
Dear learner, let us now discuss the construction of an induction cooker. The main components of an induction cooker are the cooking surface. It is the area where the induction process takes place. It is a flat glass ceramic plate surface on which we place the cooking vessel. Induction coil. It is a coil of copper wire in the beneath of the cooking surface. It generates a high frequency magnetic field when alternating current flows through it. The magnetic field is what induced the electrical current in the cookware. The next component is the control panel. The control panel is the area where we can select and adjust the various cooking settings. It includes buttons, knobs, or touch-sensitive controls for power level, temperature, timer, and other cooking functions. Air vent. Induction cookers generate heat not only in the cookware but also within the appliance itself. To prevent overheating, air vent with fans is present in the side of the appliance. It dissipates excess heat and keeps the appliance operating within safe temperature limits. Display panel. Display panel shows cooking information such as the selected power level, cooking time, and any error messages. The next component is the cookware. Induction cookers need cookware that is compatible with induction heating. The cooking vessel must be made of a ferromagnetic material such as iron or steel that has a magnetic bottom. Non-magnetic cookware that are made of aluminum or copper cannot be used as they have no layer of magnetic material at the bottom. Power cord. The induction cooker is connected to a power source using a power cord. Make sure the power source meets the appliance voltage and current requirements. Dear learner, thus we come to the end of the first two topics of this session. So far, after going through the basic operation principles and the construction of an induction cooker, let us now test our learning by attempting the following questions. After answering these multiple choice questions, let us now move to the next topic of the session. That is to discuss about the safety precautions of the induction cooker. While induction cookers are generally considered safe appliances, it is important to take specific safety precautions to ensure their trouble-free operation and minimize any potential risks. Some important safety consideration includes use compatible cookware. Only use cookware that has a magnetic bottom. Using a non-compatible cookware can result in inefficient cooking or damage to the appliance. Avoid overheating. Never operate the induction cooker without cookware on the cooking surface, as this can cause the appliance to overheat. Also avoid placing empty or dry cookware on the cooker, as it can lead to overheating and potential damage. Keep the cooking surface clean. For optimal heat transfer, the cooking surface should be cleaned. Food spills, residues and debris can restrict with the induction process and may even cause overheating. Keep flammable materials away. Ensure that there are no flammable materials such as paper towels, kitchen towels or plastic items near the induction cooker when it is in use. These items could catch fire if they come in contact with the hot cooking surface. Proper ventilation. Ensure that the ventilation area of the induction cooker are not blocked. Adequate ventilation helps prevent overheating and allows the cooling system to function effectively. Unplug the power cord. When the induction cooker is not in use or prior to cleaning the device, it must be unplugged the power cord to reduce the risk of any electrical issues. Avoid sharp objects. Do not use any sharp or abrasive objects or petroleum products to clean the cooking surface, as they can scratch and damage the glass ceramic surface and the plastic part of the cooker. Read the manual. Before using the induction cooker, carefully read the manual and follow the instructions for installation, usage and maintenance. Consult a professional. If any problems arises with the induction cooker, such as experiencing unusual sounds, sparks or malfunctions, it is important to immediately stop using the appliance and seek assistance from a qualified technician. By following these safety precautions, we can be minimizing risk and ensuring a safe cooking experience. Now let us discuss some common technical problems and troubleshooting in induction cooker. Some common issues that might encounter with induction cookers and possible troubleshooting steps are: number 1, cooker not turning on or heating up. If the induction cooker is not turning on or the cooktop is not heating up, first check the cooker is properly plugged into a functional power outlet and the circuit breaker or fuse is not tripped. Then ensure the use of an induction compatible cookware with a magnetic bottom. Next is the cooker display not working. If the display of the cooker is not functioning, first confirm that the cooker is receiving power by checking the display or any power cord and plug. If the display of the cooker is not functioning, first confirm that the cooker is receiving the power by checking the display for any signs of lighting up. Examine the power cord and plug for any loose connections or damage. If everything looks okay, the problem may be with the circuit board, E0 or E1 error code or other error codes. The cooktop may display error codes when there is an internal problem. E0 error is a common problem found in the induction cooker that may occur for many reasons. Capacitor issue is one of the reasons for it. Some other error codes of the induction cooker are E3, which means abnormal supply voltage or voltage too high. E4 error code means voltage too low. E5 means the plate surface temperature sensor short-circuited. Empty pan heating leads to a high temperature. E6 error code may be due to the fan failure. Air intake exhaust vent may be blocked. When these errors occur, check the manual to identify the specific error code. The manuals include a troubleshooting section that lists possible causes and solutions for each error code. In some cases, the error code may require professional repair or replacement part. The next issue is the overheating or auto shutdown. When the cooker is overheating or auto shutdown, ensure that the air vents are not blocked and there is proper airflow around the appliance. To prevent this problem, ensure that you use cookware that is compatible and equipped to withstand high temperatures. Opt for cookware with a thick and flat bottom, as this will help safeguard both the cookware and the cooktop. Noise or vibrations. Some induction cookers emit a slight buzzing sound due to the high frequency magnetic fields. This is usually normal. It might produce fan noise during operation. Make sure the ventilation areas are clear. Due to incompatible cookware, vibration may take place. So dear learner, here we will see how a basic problem of an induction cooker can be repaired with simple steps by using simple equipment and tools. Let us begin. Here the display is not working. So let us check the internal components. When the power is on, the fan is moving, but there is no light in the display. There is no damage in the wire, but when the wire touched, the display indicates some lights. This means there may be some loose connection issues or maybe some other problem. Now, when the power button is on, the display shows an error of E9. So, dear learner, first let us check the fan of the cooker. Its fan is not working properly and making some noise. So the fan is replaced by a new fan. Now let us examine the power cord and replace it with a new power cable and check the voltage across it by using a multimeter. As the voltage level is not showing correctly, let us check the capacitor of the circuit. As the capacitor get damaged that we have seen here, it drops the voltage level. So the capacitor is to be replaced. Now let us see again. The E9 error code caused due to the capacitor not functioning properly. Now let us check the voltage level again by using the multimeter. As it indicates correct voltage level, let us check the cooker again. whether the E9 error is showing or not. Now switch on the cooker by pressing the on switch. Now see, the E9 error is removed. Now place a cooking vessel over it and check its functioning. The induction cooker is working now. If some issues that cannot be resolved through troubleshooting, contact the customer support service or consult a technician for further assistance. Always follow safety precautions and guidelines while troubleshooting or attempting any repairs. Dear learner, after going through the safety precautions and the common technical problems of an induction cooker, let us now test our learning by attempting the following questions. Now let us see some advantages of the induction cooker. Induction cooker is a powerful cooking medium with precise and instant heat applications. There is no wastage of heat, maximum energy utilization as the energy is supplied directly to the cookware. Safety from open flames, no fire hazards and gas leakages. Once the cooking vessel is taken off the ceramic plate, the device automatically switches to standby mode. Dear learner, here we come to the end of the session. At the end, I would like to mention that induction cooker is considered as one of the most efficient technology for stovetop cooking. This technology relies on the principle of magnetic induction, in which eddy currents are excited in a ferromagnetic cookware when in the presence of an oscillating magnetic field. Induction cookers are popular for their quick and efficient heating, precise temperature control, and safety features. They are widely used in both commercial and residential kitchens as an alternative to traditional gas and electric cooktops, though the taste of food cooked in the induction cookers is not same as that cooked in gas fuel. I hope the information given in this video would help you to enhance your knowledge about the basics and working of induction cooker. Don't forget to post your questions and queries. Thank you.